In the age of generative AI, if you think that machine learning has gone somewhere, you are wrong, my friend. Let me tell you, machine learning is leading the show in most of the AI deployments when it comes to real work. I am not talking about something in air, I am talking about real work. You must know how to implement a machine learning project to be eligible to learn generative AI. And I see that missing in many people. In this video, I am going to walk you through a complete process of machine learning project implementation end to end. Do watch till the end. What we are going to do is we are going to understand this entire project in 4 phases. First phase, I am going to tell you what this project is about. So what it does from the front end. Second phase, I am going to tell you how to do the setup in VS Code or how you can set up this project in your local machine as well. Third, I am going to explain you what is actually happening in this large code base. And fourth, I am going to tell you how you can take this project, deploy it somewhere, host it somewhere, etc. So please ensure you watch till end, guys. This project you can very well use in your resume, or if you want to host it somewhere and share the link with someone, or if you want to talk in any of the interviews, all the places you can use this project. So let's see what it does from the front end. As you can see, model is selected as random forest. I have a choice of using PCA or using polynomial features. I can set hyperparameters. I can increase it or decrease it. I can choose the max depth, etc. I can use some of the parameters of random forest, and I can say train, retrain. At the moment I change this to other model. Let's say gradient boost. I can simply go and update the parameters accordingly for gradient boost. If I change it to third one, you will see that parameters are changing here. So I can adjust these parameters. Now let's go to random forest and let the default parameters be here, and let's say train. When I click on train, you will see that this model is training. Now, some of you who is having little knowledge of how machine learning works, when the training is happening, right, model is basically learning the pattern from the data. That's what is happening in the backend. What is the result of training? The result of training is a trained model. So, a trained model is a trained entity that can tell you the answers. So, when I clicked on train here, I created a model. That model can now tell me what should be the prediction. So this metric that you see here is basically test metric for the model. So for example, this is root mean square error, this is mean absolute error, and this is R squared. All these topics you can search on Unfold Data Science YouTube channel. Just say Unfold Data Science R squared, you will understand what is R squared, you will understand what is mean absolute error, etc. But currently the idea is to understand the end-to-end demo, so I will keep it into that line only, the explanation, right? These things also I have explained in my different videos. You can learn more about that, but just see what is happening here. First of all, it is trying to give you feature importance of every feature in your data. So in your data there could be many features. So one feature could be median income, other feature could be average occupant, or whatever this column is, then longitude, latitude. These all columns come from your data. So it is assigning a feature importance to columns in your data. What is the meaning? The meaning is which column is more important for predicting the target. So I have written my code like that it will show. Now here some warning is coming. I'll come back to this warning. But here basically I have used a package, and from that package it is telling you which features are how important for the prediction. If you see here SHAP SHAP value. So SHAP basically tells you which feature is important in prediction, how much. You can think like this and this are more or less same, right? But just different ways of representing. And then this is again a SHAP. Now if you want to understand SHAP, right, so I'll just show you only so that it's very easy for you. So go to Unfold Data Science and search for unfold data science SAP. Okay, so SAP is basically a way to understand how the model is making prediction. Watch this video, you will know what the charts mean here. Okay, so these are important charts which I am plotting here, but the critical thing here is the prediction. As I told you, when the model gets trained, then you can predict based on these features. So this is basically we are trying to predict the price of a house. That is what this problem is. Okay, so price of the house we will try to predict based on these features. So what we will do is we will change house age. For example, now the house age is 29. Let's make the house age as 35. And what I can do, I can simply say predict. If you say predict, you will see that it is going to give you a response. Predicted mean value of house is 2.339. Now, if you remember, the important feature was median income. This is important feature. So if I change this feature, right, then my house price will change a lot. Let's do that experiment. Let me say in place of 3.51, let's say 7.00. So I have almost doubled that. I expect that my predicted median house price will change and change by a good margin. So as you can see, it has changed by a good margin now. So this is the prediction part here. The training has happened from here. Prediction I am able to do from here. And I can choose which model I want to train on. So a new model will come into picture when I click on train retrain. So in the old model, if you remember, R square was slightly different. New model, it is slightly different. And then this, and then you can change these values and again compute the prediction. So based on the model, obviously prediction will change a little bit. If you remember, it was less than 4 in last one, the parameters remain same. And you can change the model. You can use PCA if you want, and you can retrain the model. So this project has a lot, guys, and that is the reason I am telling you this qualifies for your resume project, or this qualifies for your capstone project. Okay, this many things are happening in the front end when you are talking to someone, right? You can explain what this chart talks about, importance, how SAP works. So SAP learned from here, as I told you, how SAP works, how prediction is happening. If I change some important things, how prediction is changing. Parameters we can change here and we can retrain the model. We can get a new model and do the prediction. So front end part I explained you what all this is happening here. Now let's move to phase 2 and let me explain you how you can do the setup. So now this is running. So I will just say Ctrl C to stop running, and I will press Ctrl L to clear the screen. If you see here it's written LM. LM means I am running this code from a virtual environment. So I will first of all deactivate just to show you how it is working. Okay, so when you import this entire project in your local machine, right, you should import it as a package, and then the first thing you should do is you should set a virtual environment. That is the very first thing you should do. How to set a virtual environment is very simple. You simply say python -m venv aman. Let's say name of the virtual environment is aman. Just an example I am giving you. So name of the virtual environment is aman. Okay, so here I am aman, and then this aman virtual environment I can activate. How? So I will say aman and scripts and activate. When I do this, you will see that aman has come here, which means now I am inside aman virtual environment. What is the meaning of this? The meaning of this is a separate environment inside my Python where I can do my package installation, where I can create the suitable environment for this particular project. Okay, so it is always advised to create a separate virtual environment to work in any of these kind of projects, because you will need lot of packages, you will need a different environment, you will need a setup which does not interact or which does not contradict your default setup of Python. So better to create an environment like I showed you and then activate the environment. Now I will press Ctrl L and I will come out of Aman because Aman is not something I want to use. So I'll say deactivate. Fine. In your case, when you set up a new environment like this, you need to install all the packages first. That is the first thing you need to do. Go to requirement.txt. The normal way of installing these are simply if you say pip install -r requirement.txt, that will install all your packages inside Aman. So remember, you have to be inside Aman, then install the packages. Okay. But in my case, I faced some issue when I tried to do that. So I'll give you this readme file also. If you go to this readme file, right, I am saying quick start. First, set up your virtual environment. Then source virtual environment bin activate, the same commands that I used. And then you can say pip install r requirement.txt. When I did this, I faced issue in my local machine. I'm saying you might not face the issue. In my local machine, I faced the issue. So what I did is I followed these steps. So pip m install upgrade pip, issues was coming for me. Then I did this and then I did this. If you see, this is installing requirement.txt. So in your case, you can simply do virtual environment creation and install the packages. If it works fine, very good. Otherwise, you need to run these 3 lines and then your requirement.txt will be installed. Once you do those 2 things, right, then your environment is ready. Once your environment is ready, now I am moving to the part 3. Part 3 is what is actually happening in the code and how we are able to run the entire thing. So you can run this entire project. Let me go to my virtual environment basically. So my virtual environment is LM. Okay. So I will say LM. Why it is not okay? I should go one step back actually because my LM is one step back. So let me go there. LM, then script, then activate. So what will happen? My virtual environment will get activated here. As you can see, it's activated. Now what I can do, I can go to California housing and from here I can run my code. So my virtual environment is already having all the packages. You should install the packages. So there are 2 ways in which you can train your model. If you remember, from the front end, I was clicking this button, train retrain. This is a UI mode or graphical user interface mode of training the model. That is your first way of training the model. Is there any other way of training the model? Yes. And that way is CLI way, the command line interface. If you go to Python and if you run this command, python msrc.train model random forest fast, what is going to happen is it is going to retrain using random forest. So imagine you are choosing here random forest and you are choosing default parameters. That will do the same job which this command will do. And if you want to evaluate, you can evaluate using evaluate command. So you can try these 2 commands. I can also run it and show you. For example, let me try to show you that random forest training from the CLI command line interface. So as you can see, the parameters starting training model with random forest, use PCA false, use polymal false, fast is equal to true. And then setting hyperparameter search with 5 iteration and 2 CV folds. What is happening? Model is training with the default things that you have given. This is a command line interface way of training your model, and that was a GUI way of training the same model. I hope you understood this difference. So this is how you can use it, but more important for us to understand how the entire pipeline is running. So let's go one by one. First of all, This is a California housing regressor data. This is an end-to-end machine learning project that predicts median house prices from well-known California housing data. Okay, so California housing data is a well-known data. In this, my job is to predict median house prices, and whatever column you saw in the front end, right? Average bedroom, latitude, longitude, house age, median income, all these columns will be used to predict the house prices. That's what this data is. So your target column is median house prices, your independent column is these columns. This is a regression scenario, right? This is your data. Now I'll explain you what are the different things that is happening in the project. First is data ingestion. If you go inside the source folder, right, you will see there are a lot of Python scripts here. The very first script is data.py, and here the data ingestion is happening. So if you see here, right, load data set, load the California housing data. Okay, and if you see fetch California housing, so the job of this particular Python script is it will give you the data, train and test data. Basically that is what the job of this. Okay, that is the first one. The second one, if you see, pre-processing, where PCA and optimal polynomial features are happening. So let's go here and you can go to features.py, and here you will see PCA, pipeline, polynomial feature, standard scalar. So some feature engineering is happening. So build preprocessor, and we are defining the arguments, use PCA, use polynomial. If you remember, these were the things in the front end also, right? What we are doing, if use polynomial is there, then steps.append poly. So basically if the user says I want to use polynomial, then this step will get appended in the pipeline. If somebody says use PCA, that will get appended in the pipeline. So this is build preprocessor. What is the next thing? Models. So it supports multiple regressor like linear regression, random forest, gradient boost, XGBoost regressor, and hyperparameter is also tuned. So if you go to models.py, right, gradient boost, random forest, linear regression, whichever model user chooses, right, that model will get called. So linear regression, random forest regressor, gradient boost, gradient boosting regressor, XGBoost. Sometimes if XGBoost is not available, it will give you error, otherwise XGBoost regressor. And then parameter distribution. This distribution are used with randomized search CV. So all the hyperparameter is not applicable to all the models, right? So for random forest, these are applicable. If you remember, in the front end when I changed the model, parameters also changed. For gradient boost, these things. For XGBoost, these things. All the model related thing we are doing here in models.py. What else is happening? In evaluation, we are computing root mean square error and mean absolute error and the coefficient of determination. So if you remember, the first thing on front end was these things only. See, root mean square error, mean absolute error, and R square. Where are these things getting calculated? In the evaluate. Come to evaluate, and you will see that through all these packages we are simply computing those things. So if you can see, stratified split is happening and R square is getting computed, MSE and mean absolute error, these things are getting computed here, right? What next? Explainability. So I told you SHAP is being used here. Use SHAP for global and local interpretability. So I will tell you one more time, SHAP is an important thing in the age of AI now. You must know about SHAP. Go and read about it, okay, in this video. So through SHAP we can tell which feature is doing what in the prediction, and that logic in our code is in explainable part, explain. Okay, so here if you see compute SHAP value for a given sample, if SHAP package is not there, then something else is working, otherwise SHAP will work. SHAP waterfall, and then you can use this SHAP package and get the responses. What else is happening? Streamlit UI is the UI that you saw is responsible for the front end. Okay, and then testing is basically for testing. So there is a folder called tests. If you see, there is a folder called tests. In these tests, right, you can run multiple tests, like for various runs, right, contain PyTest suits that verify data splitting, proportion, pipeline construction, CLI commands. So basically testing is happening here. This is also one important part of any production grade machine learning pipeline. So we are doing some testing that all the things are working fine. This is about your flow, but all the things are happening inside Streamlit UI. I mean, the backbone is these scripts, but how these scripts will be used, that is happening inside app.py. So app.py is here, and in app.py, right, you will see that all those scripts are getting imported from src.data, load dataset, strify, .features. .features means what? Go to src. This is features. From features, we are trying to import build preprocessor. So go to app.py. From features, build preprocessor. From models, get model and get param distribution. Now go to models. So get param distribution and get model. These two we are importing. Then let's see one last thing. From utils, load config, set seed. So here utils will be there. So set seed, get logger and load config. So these things we are importing. So what I'm trying to tell you is all the main scripts are here. App.py will call those scripts one by one, and based on this situation, so what it will do, it will first load splits, it will create this split, then it will train the model. So every time I'm clicking on the train retrain, right, it will train the model, it will create the pipeline preprocessor, pipeline.fit, prediction, mean absolute error, mean squared error, r square, and it will return pipeline metric xtest, ypred xtest. So basically training and evaluation. Then if SAP is available, it will go and do the SAP work, and in the main, right, so use PCA, use poly, these things were there in the front end, if you remember. If model is random forest, then it has to show these things. If model is gradient boost, then it has to show these things. If XGBoost, it has to show these things. And where from these will be taken as input? It will be taken as input from user selection, or there will be a default value. Button to train retrain, if you remember. If trained, not in session state, means if the model is not trained, then it will take as session state as false, means model is not trained. If it is train or retrain, then it will start training model. Spinner means in the beginning you saw there was a spinner coming saying training model, and then the train model function will be called. This is the function which is responsible for training your model. So from src.models, right, it is getting get model and get param distributions. So basically what I'm saying is from the models file, it is taking some of the functions and using it into this file, not some of the functions, actually all the functions, and using it into this file, and then going to the next steps and training the model. So here the training, actual training will happen, and then as you can see, basically these are all what it will show in the front end. So front end stuff here, and then main function will get called. So this is about end to end how app.py will run. Okay, so third part is mostly about understanding how your project is running. What are the critical parts? Inside src all your scripts are there, inside test all your test things are there, inside logs when you evaluate or train, the log will go and sit, inside config all your default configs is there, inside artifacts model will come and sit, inside aman is basically what I created now to show you. I can delete this also. Okay, and this PyCatch is there. Now this model is running very nice in the local environment. So what is happening here? In the local environment, my model is running very nicely. But what if I want to take this model and run it on some other environment? That is the last part, last bit that I told you. What if I want to take this model and run it on AWS or run it on some other server. What I need to do for that? What I need to do, if I want to push this model to Git and then integrate that Git to my AWS, what I need to do for that? So if you see here, there is a file called Docker file. In this Docker file, there are some commands written, and all these commands has some meaning, some value. If you want to migrate your code from one environment to other environment, you will need Dockers. And if you want to push your code from local to Git or any kind of repository, you will need Git. So I have a Git ignore, but you can add your own Git files here as well. For both of these concepts, right, I have created detailed courses on. So let me try to show you which courses I'm talking about. Every time you talk of deploying a model in production, you cannot avoid these two concepts, guys. One is called Dockers, another one is called Git, GitLab and CI/CD. In any of my video, for example SHAP video also, if you go right, you will find the links here. First course is Docker for beginners. This is on Udemy, and this is already discounted link that you are seeing here now. That is for my subscribers only and for data science subscribers only. If you watch this course, right, 1 hour total only, if you watch this, you'll be very confident on what Dockers are, how it works, and how you can migrate your application using Dockers. And if you watch this Git, GitLab and CI/CD course, which is again on Udemy, you will be very confident on how to work with Git, GitLab, CI/CD
in this lecture,
and AWS. So I have started from the scratch. I have explained understanding the branching in Git, learning GitLab, understanding and building CI/CD, deployment in AWS. Many things I have explained one by one. Again, this is also not very long, 2.5 hours only. Please consider taking this Docker course and this Git, GitLab and CI/CD course. What will happen is, whatever I explain you now here, if I do it myself and push it somewhere, you will not be able to digest it. You need to do it yourself using Dockers and Git, GitLab and CI/CD. For that, you must learn from these courses, because these courses will start from scratch and make you an expert in these. So go ahead, take those courses, take this same project which I'll upload in my GitHub, take this project, learn the concepts, try to deploy it somewhere and share the link with me. I'll give you feedback, personal feedback on how things are looking like. Okay, but I'll just reiterate 4 parts that we have covered. First part is, what is this project front end all about? What is this project doing? I explained you. Then I explained you how to set the environments. Then I explained you what is happening in this all scripts and how to call them, how to run them. And then I explained you how you can go and learn about related concepts so that it's easier for you to deploy the models. Please let me know if you have any doubts, guys, and I'll see you all in the next video.